Good morning, friends. It's Mr. T. Want to do a short follow-up lesson to the astronomy lesson from yesterday. We talked about the origin of our solar system. And just for review, you might remember that there was this nebula in the Milky Way galaxy, nebula being the birthplace of stars. And there was this clump of debris from previous supernova that was floating about in the nebula. And it was a mixture of gas, particularly hydrogen, helium, some dust, and other elements. And that mass was disturbed. We don't know exactly what, but maybe a supernova nearby put a tremendous amount of energy into that mass and started spinning. And as it spun faster and faster, it became like a plane, like a plate. And so it was spinning like maybe a frisbee. And then over time, as the particles in that spinning mass began to accrete together, the core formed. And the core was this core of hydrogen gas. And eventually, when the mass became dense enough and hot enough, it burst into a nuclear fusion furnace. And that was when our sun, our star, came to life. And in the process of it coming to life, it generated a solar wind, a tremendous amount of energy that blew the gases that had been in the cloud out into the distance of our solar system. And it left the rocky, heavy element parts in closer to the sun. And that's how our solar system was formed. That's how we get the rocky planets in close to the sun, the first four, and we get the gaseous giants out to the distance, way far out away from the sun. You may recall also that in between Mars and Jupiter, the gaseous giant and the last of the rocky planets in Mars, there's this band of debris, of junk left from the formation of our solar system. And it's called the asteroid belt. And the asteroid belt has objects of all shapes and sizes in it, and different mineral compositions, depending upon the elements that accreted together and were left as these huge, like boulders out there in the asteroid belt. Well, Mr. T has something very special. It's one of my prized possessions. And I bought it at a geology store in Los Angeles some years back. And, the store had all kinds of precious rocks and stones and all kinds of minerals and elements, kind of like the stuff you see in the Smithsonian Natural History Museum, but, smaller things that were actually for sale. And I managed to purchase this, and I'm going to show it to you. And I have posted some pictures of close-ups of it on your Facebook page. But this is an actual meteorite from outer space. Wow, it's so precious. And you see how it's all craggy and ill-shaped, like it's been melted. And then came back together and hardened. Well, let me tell you about meteorites. So meteorites are parts of comets or asteroids or meteors from far out in outer space. In fact, astronomers believe or know that these meteorites are actually part of the original formation of the solar system. They're the junk that did not accrete and form into planets. So that makes these objects, these meteorites, 4,600,000,000 years old. Look at that. That's the oldest thing you'll ever hold in your hand. And I'm really sorry that we can't be in school today, because I would certainly love to have you hold it. And when we go back to school, remind me to show it to you so you guys can hold it. 4.6 billion year old meteorite. When comets or asteroids or meteors come into the Earth's atmosphere, because the atmosphere is dense gas, it causes a tremendous amount of friction. It's coming in very fast, hundreds of thousands of miles per hour, okay, very fast. That generates a tremendous amount of friction and heat. There's chemical reactions between the gases in our atmosphere and the minerals and elements that are in the asteroid. And what happens is the asteroid breaks apart, smashes it into bits as it comes into the atmosphere and gets closer, coming down to the Earth. There have been, up to 2018, there have been recorded 59,200 actual meteorites landing on the Earth. So it's fairly common to have that happen. The oldest one that we've ever found, and it can be dated by carbon dating. Geologists can date these the elements in these meteorites. The oldest one that was found was landed on the Earth 3,200 BC, about the time that the pharaohs were building the pyramids. So they've been around a long time. The composition, what survives, the minerals that survive, the elements that survive that traumatic entry through the atmosphere and that tremendous heat and pressure, is iron and nickel. This is very heavy for a small little piece like this. It's solid iron and nickel. Those of you who have been to the Natural History Museum with us, and we've gone to the area where, in the geology department, in the geology section, have seen those giant meteors that you can actually touch. And they're solid nickel and iron, just like this one, but this one's very small. And this one Mr. T owns. When those meteorites hit the Earth's crust, they hit it with tremendous impact. And there, around the Earth, there are many examples of craters, huge holes in the ground that have been left when these meteorites smashed into the crust of the Earth. One of the biggest ones is the Barringer crater in Arizona, and it's 3/4 of a mile wide. So I want to tell you about meteorites and have you follow up and look at the pictures that I'm going to post for you on the Facebook page, and have you work, if you like, in anticipation of our lesson next week, which is going to be on the planets. In anticipation of that, you can work on those two worksheets that Mrs. Kiefer has posted for you, word studies and word puzzles on the names of the planets and some of the astronomical phrases that we use in our science discussions. So this is Mr. T. Hope you have a great week, and we'll see you again this same place next week. Have a good weekend. Mr. T out.